Tēnā koutou, kia ora koutou katoa. E ngā manuhiri matararahi. E ngā homahi, e ngā tawira, e ngā kaito toko, me ngā hoa. No mai, haere mai ki te whare wānanga. My name is Margaret Hyland, and I'm the Deputy Vice-Chancellor Research, and I'm here to give you a very warm welcome on this grey winter Wellington day to our Spotlight series. And I confess this was a bit of an experiment to run an 8 a.m. lecture. Looks like it was a good one. Welcome to this lecture. Can AI language models be used to improve the efficiency and effectiveness of the public service? This is one of the first events being hosted by the Policy Hub, which is being established at the university as a way of advancing our relationship and our conversations with the government. And one of the first sets of activities that the Hub is leading is about the use of AI in the public sector. All around us, there are significant asks for evidence-based policy and practice. Education, social welfare, justice, environmental goals, healthcare, whatever the field, this holds true. In Aotearoa, New Zealand, universities and our research staff enjoy valuable connections with government and policymakers in areas like health and environment. But there are other areas, especially among the emerging ones, where there are critical gaps between research expertise and informed policymaking. The key reason that I was keen to have the Policy Hub set up was to help bridge this gap, to facilitate the conversations and interactions between our researchers, public sector agencies, and policymakers. A key area of focus for the Policy Hub is making our research more accessible to decision makers, and a bit the other way around to help our researchers understand how to do that connection with policymakers, to ensure that academic evidence underpins policy decisions. And the topic that we'll be hearing about today is one of the 4 areas that the Policy Hub is currently focusing on. And in addition to this workshop, the Policy Hub is also supporting various government departments as they consider the appropriate assurance approach that the public sector should adopt to maximize social benefit while effectively managing risks from the use of AI. Once again, I'm delighted to welcome all of you to this session. I look forward to hearing Ali and Simon's thoughts on the opportunities and the risks ahead, and to the discussion that I'm sure it will spark. And as you can tell by our pre-intro intro, Simon and Ali are not shy and will introduce themselves, so I pass it over to them.
Thank you. Kia ora. My name's Simon McCallum. I'm sort of the intro act of the fun, enthusiastic puppy in this room, where I'm kind of, yeah, AI is amazing, it can do amazing things. And then Ali tempers me with the, well, but. And so we've actually been doing this dog and pony show for about 20 years, right? Because we started first working together back in Otago about 20 years ago. So I got my PhD from Otago in the functional purpose of REM sleep. And I was looking at the way the brain functions, right? So my PhD is more in neuroscience than just computer science. But a lot of what I was studying and I was learning and the models I was building back in the late 90s have actually been sort of evolving to the point where now they form some of the core of what's in ChatGPT, the neural networks that are buried deep in the language model. Now, yes, Ali and I have both been teaching AI for many years. I moved into teaching game development, and you think, well, why would game development person want to talk about AI? It's the innovation that happens in the game industry and the constant change that has meant that when I see AI, I see it as this change agent. It's constantly changing things. And so my experience in the game industry is actually quite useful here. And, you know, I've taught in Norway for a bunch of time and I've currently still working in Norway. So I do a lot of remote teaching. So yeah, this is kind of pan spanning the world. At Victoria, we've got a new bachelor in artificial intelligence. So we're graduating our first third years this year, right? So they're currently, they're currently planning our third year. We'll graduate them next year. I'm graduating my first game developers this year. We also have a master's and we have many PhD students working in the field of AI, right? So we've got a lot of research happening at the university. And as we said, we're working on government policy around this because what was just an ivory tower thing is now washing over the rest of the society. So generative AI, that's the big thing, right? ChatGPT, it's the kind of, wow, suddenly AI is able to make things that make it feel like it's doing stuff at a human level. It's doing things that we thought only people could do. And so when you look at what it's doing, it is able to extract meaning from language, right? That is a really kind of deep concept, that it's not actually doing great reasoning. It is just doing this extraction of meaning, and then it uses that meaning to develop new content, right? So it's doing this kind of understanding at a level which our intuitions don't tell us a lot about what's going on inside the machine, right? Because when we talk to other people and they understand something we say, we can infer a whole bunch of things about what's going on inside their head that they're able to understand this meaning. But we can't do that with an AI, right? The AI is extracting meaning from language in a different way. So we can talk about how that works, and we're going to talk a little bit about what AI is good at. So how the AI works. As researchers, as scientists, as a university, part of our job is not just to work out how to use something, it's to kind of, rip it apart and find out how it works on the inside. So as part of that, when we look at the opening statement for today's session, we have artificial intelligence is advancing, and what ChatGPT does is, this is actually the tokenizer for ChatGPT. It turns each of those words into a token, into a number. Now, interestingly, the word artificial isn't in its vocabulary, right? AI doesn't know the word artificial. That's 2 tokens for it, right? Because it didn't appear in the first 80,000 words, right? Actually about 90,000 words, which are its vocabulary. So those 90,000 words, you can see each of those tokens is a number between 1 and 90,000, and those are how it extracts and separates out language. It then takes that and turns it into a massive representational vector. And so the idea here is that instead of taking each word as a symbol, as a thing in itself, it tries to separate it out into the components that make up that word, right? So a word like him, right, is actually, there's depending on your token size, about 1,000 to 4,000 vector space. And what I mean by that is you get like a number, like negative 0.0147, and the next one is negative 0.002. There are 4,000 of those numbers, and they represent the word him. And the word her is a slightly different representation. But mostly they're going to be the same number, and mostly around 0. But there might be a number somewhere in the 1,000, which is a kind of gender number. And it will go, oh, him is going to like +2, and her is going to be like -2, right? They'll spread out, right? They'll separate on a particular part of that representation. But you also, with him and her, you also have, both would have a high personhood number, and both would have a high relating to society number. And so they'd have a collection of numbers. Now we can then try and map some of that. If we just, instead of having 1,000-dimensional space, because you can't get your head into that, if you look at it in 3 dimensions, you can start thinking, well, that vector that represents man, right, and a vector that represents a woman would be similar to the vector that represents him and the vector that represents her, but there's some sort of personal pronoun thing that's been added. What I can do is I can look at that space, that massive dimensional space, look at the difference between man and woman, And if I applied that difference, right, I look at okay, this is how man is different to woman. I took that difference and applied it to the word him, I would expect to find the word her, right? Because inside that representation, it's represented these relationships between the meaning of words. Right? Now, and we can see that it actually does work. It does it for capital cities. There's a concept of capital cities. There's a concept of timing. These are all concepts that are baked into those 4,000 dimensions that it's able to extract and use to move around. And what we do is we call these embeddings. Now, if you've been following the news, Microsoft have just released Copilot Plus PCs, which use these embeddings to take everything you do on your computer and store it by meaning, right? Because what's doing is it's turning like words and sentences and paragraphs into these conceptual meaning. And so what they've just recently done is they also add screenshots to that. So it's constantly watching you and it's storing all of your screenshots in this meaning space, right? And then you can access it by saying, well, you know, when was I talking about cats? And it will find everything that has a similar representation and bring that back and show you what you were doing. So you can imagine you'd have this multi-dimensional space and you have a point that was meaning and then the things around it. So if we have that representation, and if I was to say there was someone who was positive on power, positive on female, positive on UK, positive politics, positive on 1970s, who would you guess that was?
Tracy Chapman.
Right, so and Ali's language models, Tracy Chapman,
Thatcher.
Margaret Thatcher. And yeah, in fact, you find that Claude built the Margaret Thatcher concept, right? And it triggers not just on her name, right? So you see here that it's triggering on her name and her name there, but it also triggers on the word her in the middle of a sentence about Margaret Thatcher, right? Because it's not searching for the word Margaret Thatcher, it's searching for what is the thing that most triggering the concept Margaret Thatcher, right? So that's how these language models are working. And in fact, Claude, what you can do with it is you can also get it to drive the Margaret Thatcher concept. So they could get the LLM to believe it was Margaret Thatcher just by getting into its brain and driving up all of the concept that was Margaret Thatcher. So it would answer as Margaret Thatcher. You ask it who it would say it was Margaret Thatcher. So though you can do interesting things in sort of neuroscience. Now, there are lots and lots of models, and there are too many and they're developing too fast to keep up with. If you're interested, although you can't see that there, if you go to Hugging Face, that's got a great list of models, hundreds of thousands of systems that are out there. Oh, and I put there. So there's been recent announcements. I said Copilot PCs, OpenAI, their 4.0 is still reasonably recent. That they're hinting that 5 will be out in the next couple of months. So there'll be another jump. Sonnet from Claude from Anthropic is really good, and I'll show you some artifacts in just a sec. And Google and Apple have both said that this generative AI is coming to your cell phones, right? So it will be part of every operating system you use. There will be generative AI that is built into your laptop. So it won't be a cloud service. You will be doing the encoding and the embedding and generating of language on your own machine, right? So when we talk about bring your own device, you will bring your own language model on your laptop to work, right? So that's going to be a massive change, that it is not just an odd, unusual thing. Now, with these AI systems, we're no longer just dealing with a language model, we're dealing with much more complex systems. So for example, in ChatGPT, there is this GPTs system, which is where you can tune a particular GPT. And if I show you here, last night, I created and I'll just make that larger so you can see it, an NZ budget expert, right? And what I did is, whoa, okay, that got confused. I made it too large. So a New Zealand budget expert, I did this using the Create, where I just talked to the AI about what I was trying to create. in the configuration, it then wrote the instruction set about what it expected to do. And I then added the, oh, and if I can get my mouse pointer to actually grab the right part of the screen. There. I added the BFU for 24 and the BFU for 23 and the data tables as Excel spreadsheet. So I just added those in. And now this particular language model has access to all that information.
Those are budget updates.
Yeah, those are the budget updates and the financial updates for the budget, both as the expense tables. And when I can now ask it questions here, and I asked it a question, and then it generates all of this context. But what it's doing here is, if we have a look, I asked it, create a graph of the difference in funding levels for education versus the military, for example, right? And what it does is it doesn't just use a language model. It doesn't just kind of try and ingest all the meaning and go, well, can I extract meaning from here? It starts writing Python code. But what it does, so it writes some Python code, it then finds that it's got some errors in the Python code. And so it analyzes it and go, oh, I got errors. Let's write some more Python code and extract some additional information about what the tables are. And then having extracted information about tables, it then tries again to write Python code to extract information. So this is showing what we call agentic behavior, right? I've given it a task, it then starts extracting information, it writes code to extract information when there are errors, it fixes that code, writes new code, because it's learned, right? So we've taught it that it's not good at numbers, but coding is good at numbers. So instead of trying to extract numbers directly by going, oh, 3 is a concept of a small number, 2 is the concept of a small number. Therefore, if I go to the supermarket with 3 children and I return home with 2 children, that's fine, because it was the concept of small children, right? Small number of children, I still have a small number of children. What's your problem, right? So we've learned that it's not good at math, right? So what it does now is it writes computer code that extracts numbers and processes them with code so that it can get the numbers right, right? So that's one of those big changes, is that we're no longer looking, and I can show you in real time when we ask questions, I can show you in real time how that works, but it will go through this process of generating code, and it will generate graphs, and it will generate artifacts. In fact, Claude will generate websites, and I can generate interfaces in real time. So I have all those demos we can show. This is part of what I was saying, agentic behavior, where it starts building stepwise processes on top of just giving you a chat response. Right? So that's where this is going. Now, when we start looking at how we can make government more efficient, the idea that we have a tool that can write code for us, that can draw graphs for us, that can step through problems with us when we steer it, makes us massively more efficient. And so, as I said, it's coming to all devices. The Windows Copilot PC did pause their recall function because people felt that doing a screenshot every 3 seconds and storing everything you were doing on your laptop in plain text on your laptop might be a security problem. And so they went, oh, we don't know how to solve that, so we'll just turn it off. So you can buy the PC, but it's currently turned off. But they're going to turn it on? Probably. And we don't know what that means when we have perfect recall on everything you did by accessing a language model that can extract all that meaning, can write code to extract data, and can generate visualizations and context. So with that, I was going to hand over to Ali.
This feels like being in church, do you think? It's like the Church of AI, or something about, I'm going to tell you about your new masters or something like that. It's early in the morning and it's like, you know, it's spread like that. Here's the pulpit. So I'm doing the kind of like the hellfire and brimstone part. Generative AI is the focus. We're not just talking about AI. There's all sorts of AI stuff that does rather, conventional, normal things that have been done for years in government and industry, predicting outputs from inputs and so on. This is generative AI, and this is this more creative thing, and that's the focus for today's seminar. And like Simon just showed, it can do amazing things, and there's all sorts of potential for this to make efficiencies in any organization, government or other. But it comes with special risks, and I'm thinking about the risks specifically of large language models, which is most of what Simon was talking about. Simon was also talking about AI that can generate in other modalities or that can interact between other modalities in language, but I'll focus on language here. Because I think that, like in public service, most of what's going to happen will involve language processing in this generative world. So I'll mention a few risks. So one of them is that the output of a large language model, it generates some text, let's say, in response to a question you have, or it might even generate some code, but that can be unpredictable, and that makes this software completely different from anything that you will have seen before. So I just want to put some examples up. When you buy software, it's been tested in-house, and then when you get it, it comes with certain guarantees. So for instance, a spreadsheet is a good example. Like if a government department was buying a spreadsheet, they wouldn't have to go away and test it because, they can rely on it working out of the box. And, the same with the word processor, if you're, a personal user or something like that, or you don't have to do that. And you might have to check things like, is the privacy settings right? Or, is people's personal data being safe? And those kind of questions. And those are sort of the due diligence processes that people are used to doing. But you don't just do those things. You have to do more than that with generative AI. And that's because these things are required through machine learning. And what that means is that, they're trained on one set of data, and then they're deployed somewhere else, I suppose. And that's true with all machine learning systems, including the kind of old-fashioned ones that we understand quite well. They operate on inputs that they've never seen before. So all those examples that Simon was showing, he's typed a prompt to Claude or to ChatGPT that it's never seen before. And so we're in a slightly different situation from, a situation like a word processor or a spreadsheet where you can kind of prove that the code does what it's supposed to do before you release it. So the sort of the key point here is that language models are not normal software, and you need to treat them differently with more caution. And now I want to talk about the particular sort of machine learning which gives you a generative model, because it's different from the normal ones. You can trust some sorts of machine learning devices more than generative AI. And this is because the traditional machine learning systems are trained to do one particular task and then deployed in the field to do that same task. So let me give some examples. Let's say you have something that takes an image of a mole or something on your skin and tells you yes or no whether that's cancerous, something like that. Okay. The system is trained on exactly instances of that task. Lots of skin cancers which are yes, no cancerous. Lots of skin lesions which are yes, no cancerous. Or here's another one, a system for predicting hospital bed occupancy. You train it on a bunch of data about actual hospital bed and how long they were there for. And so you're training on one task and then deploying it for exactly that same task. But language models aren't like that. And generative AI in general is not like that. A language model, Simon didn't mention that, but they're trained to do something very different from what he was using it for. And that's a key point, right? So a language model is actually trained, the way that it's optimized is it's trained to predict the next word in a sentence or the next word in a text. It's like, if you have this word, if I say, LLMs are trained to predict, and I let you complete the next word, that's the task that language models get good at. So they're good at continuing texts in coherent ways. Does that make sense? That makes sense. That's what they do. But that's not what they're used for. The tasks that they're used for are defined much more abstractly. Answer this question, write this piece of code. So the reason why they can perform lots of those tasks very well is that they're trained on a huge amount of data, and they've got very clever ways of generalizing away from that data. So they're good at doing these new tasks, these more abstractly defined tasks, which kind of boil down to this kind of word prediction task. If you ask it to answer a question, it predicts the next word of your request, and then the word after that, and the word after that. And that's how it ends up producing a text. But that doesn't guarantee that the output is going to be the right answer to the question. So it allows them to perform very well in many cases because it's able to generalize so well and because it knows so much. And these days, like Simon was saying, you can give it particular documents and say, refer specifically to those documents. And that helps it, deliver sort of like meaningful answers. But underneath, inside the guts of the thing, it's still just trying to produce coherent text as its output. And that means it can mess up spectacularly And people have come across, you would have seen in the news this concept of hallucinations. I won't talk in detail, but that's the problem that arises because they're used on tasks that they're not trained. Here's another one, being a little bit controversial here. Actually, this is the same risk. It's not a different risk. So I'm being very technical with this use of the word bullshit. There's this beautiful work by a philosopher called Harry Frankfurt called On Bullshit. I recommend you read it. So he has this beautiful, this is like a needed definition. For him, bullshit is a technical term. It means speech intended to persuade without regard for truth. It's like just flanneling on to indicate that you know something. So a few examples that he comes up with, like a student who's writing an essay or answering an exam question. They don't know what anything, and so they just write something, right? To try and persuade the marker that they know something. That's in technical sense for Harry Hamburger bullshit. The politician who says something with the intent to please voters without regard to the truth, right? So he says that bullshit is even more damaging than lying because you're not even trying to deceive. You're not trying to convey facts. You just don't care about the truth. What you're trying to do is to just present kind of coherent looking words that seem to follow the words that you've just been given, right? Does that even make sense? I'm being a bit provocative. So there's an interesting paper in Ethics and Information Technology, just a couple of months old, no, a month actually, arguing that the LLMs are bullshit. So worth a look, both at the original paper and at that. So here's another risk. This is sort of like, this is a bit of a different one. So now we're talking not just about the fact that language models were optimized, really carefully optimized for producing the next word, but are used for some other tasks. This is a fact about their inherent operation, which has got a lot of rolling of dices in it. So language models produce their outputs one word at a time, or one word token might produce half of the word, as in Simon's case. And each word they choose, they actually have a probability distribution over all the words or all the tokens in the language, and then they pick randomly from those with a preference towards the ones which have got higher probability. But if you ask it, the next time round, you're probably going to get a different answer. And if you you can turn down the temperature in many of these systems, and so that it's more reliable. Actually, it's quite difficult to get it to be completely reliable.
Yeah, no, there's still some non-determinism in the way the graphic cards work. And so like floating point numbers are always a problem for maths because when you calculate them, so it still does a little bit variation.
But this makes it wildly different from most of the software that we know about. And so again, I'm just being I'm being sort of like preaching caution a little bit here. Out of the box, they choose stochastically from the predicted distribution, and you get a different output each time. And then, because you produce one word at a time, there's a randomness which is compounded by another randomness and another randomness and so on. It's like, are we okay with that? Okay, so do we really want to deploy large language models or other generative tools that work in that way and using them as public service? I'm being provocative, right? I'm being alarmist to make a point, because I think they do have a great use, but we have to be really careful. And my real point is that if you're going to use it for some particular application, you need to evaluate the hell out of it. Wherever you are looking at. And you need to be very pragmatic, very empirical about this evaluation. Evaluate it many times quantitatively, and then see how many errors it makes, see how many awful errors it makes, and so on. So that's my real point. You can't just look at a few examples, because there's this kind of tendency for the good uses or the clever outputs of a language model to disseminate around, because that information spreads in situations where we're surprised or amazed and stuff like that. And so we say, hey, wow, this looks good because I've seen one example, but that's just like an availability heuristic that we should be very cautious about. So then you need very kind of systematic due diligence processes, and exactly what those should look like is still being developed. Basically, this is an active area of research. How can you quantitatively assess the performance of a generative AI model for some particular task? So yeah, like I say, it's actually still basic research. And so again, New Zealand government departments should be looking into this because we don't want to fall behind. But at the same time, we need to realize that what's going on is still being worked out at the level of research. So we have to be cautious. So I'll sketch a couple of things which are sort of like being used at the moment in the field, in the research area. One thing is to say that we need separate evaluations for each task, okay? For each task, we design a prompt, and Simon showed you a few of those. And then there's a broader architecture these days as well, where you might have some particular document that's to be focused on, and there might be agentic kind of processes that you have that might iterate over some things, and there might be controls at the end to sort of check outputs and so on. For all of that, you need to design one of those. And when you have something decent, then you need to evaluate how well your custom language model works for that particular task. And what that means is doing lots and lots of trials on lots of plausible inputs, and then quantifying how well it performs. In what percentage of trials does it work well, and what percentage of trials does it work badly or awfully, and that sort of stuff. So all of AI involves quantitative evaluation. That's how you do training in the first place. And so this is no different from there, except out in the places where people are using AI, that's not necessarily widely enough known. So that's my job. If you change your prompt or change your architecture, all bets are off. You might have to start again and evaluate again, because you might have changed something quite fundamental about how it works. So how do you evaluate a language model on some specific task, let's say in the New Zealand government or something like that? There's benchmark methods which get widely used in research, and these are used to compare Claude and ChatGPT, different versions and so on. And what you do is you have a bunch of examples of good task performance. For this output, here's a good output. For this input, here's a good output. For this input, here's a good output. Those are created by human experts. And then you can run your own system against those and see how your system's outputs correspond, with the gold standard ones. In those cases, if you want to do that properly, you need really quite large sets of example queries and responses. And then once you've got that, then you can evaluate automatically, which is quite nice. And so if you change your query or change your architecture, change your prompt, you can run it again just by pressing, go away and evaluate on that benchmark. However, benchmarks have to be big, and I'm not sure that New Zealand government departments have the resources to create benchmarks for all their tasks. There might be a better way. And also the automated marking methods, which are basically ways of comparing two free texts to see how similar they are. Those are also a work in progress. So the second thing you can do, and this is where I'll finish, so there's time for questions, is to use more like a human evaluation method. So here what you do is you just, you set up your language model to do a task, and then you just ask a human how well the system responds in this case, in this case, in this case, in this case, for 1,000 or however many examples. And so there's some painful labor there for the human evaluator who's supposed to sit there and sort of like grade the LLM's responses. So there's no automated scoring process because there's just a human who's giving intuition about how well things work and giving a mark, basically. So the human can assess the language model by itself, just on an absolute scoring scale, or they can assess the language model in relation to a human expert. So that's like a sort of Turing test. So the language model versus human tests are particularly useful because you want to know, is this a task, which is being better done by the language model than by a human employee? Human employees make mistakes as well, and we need to evaluate those too. So like my sort of finishing point is just that for your New Zealand government department, that might be the way to do it. And I think I'll finish there.
And I hate to have to draw this really fascinating session to a close. I think it was a really amazing and stimulating way to start our day. Poses lots of questions, shows the possibilities, shows us what our responsibility is in evaluating when and how we use these tools. But also, I think the other key point was that let's do that collectively, because I think the shared effort will help us all move forward. I know you'll have a million further questions. Ali and Simon are available, but also contact us through the Policy Hub to see if we can facilitate some of those shared conversations. So finally, just join me in thanking Simon and Ali for an amazing presentation.